for some instruments, there is always a difference in the reading of the instrument and the actual measurements, as you can see in the picture in front of you. Okay, first of all, let us see how to add up the uncertainties. You have two values. Measurement 1, for example, 8.2 plus minus 0.1. Measurement 2 is equal to 3.7 plus minus 0.2. And you have to add up these two values. Simply 8.2 plus 3.7, that's equal to 11.9. Add the absolute uncertainties together. So that is 0.1 plus 0.2, and that's equal to 0.3. If you have to subtract the uncertainties, for example, you have two values, 15.6 plus minus 0.4, and second value is 9.3 plus minus 0.3. How you will do subtraction? 15.6 minus 9.3, that's equal to 6.3. And for the absolute uncertainties, just have to add up the two absolute uncertainties. So that is 0.4 plus 0.3, and that is equal to 0.7. If you have multiplication, for example, two values, 8.2 plus minus 2%, and remember this is the percentage uncertainty, and you have a measurement 2, for example 3.7 plus minus 1%. Now you have to multiply, for example, so therefore 8.2 times 3.7, it's almost equal to 30.34. So if you have to calculate the percentage uncertainties, what you will do, the percentage uncertainties will be added up. So that means from measurement 1 we have 1%, from measurement 2 it's 2%, so together we have 3%. Division, you have two values, 15.6 plus minus 1% and 9.3 plus minus 2%. If you have to divide 15.6 by 9.3, your answer is 1.6774. And the addition of percentage uncertainty is 3%. So in order to calculate the absolute uncertainty, you will multiply the result by percentage uncertainty and then divide it by 100. So therefore 1.6774 times 3, and then I divide it by 100. So my answer is 0.05, and the final answer is 1.6774 plus minus 0.05. Uncertainties and graphs. The error bars represents the uncertainty in a measurement on a graph. So this bar is actually the representation of the uncertainties, as you can see on the two graphs below. In order to calculate the uncertainty in a gradient, you have to find out two lines of best fit which shall be drawn on a graph. You know that the best line of best fit is the line which passes as close to the points as possible. The worst line of best fit is the steepest possible or the shallowest possible line which fits within all the error bars. If you see this graph, there are three lines. One is the line of the maximum gradient, and the one is the line of minimum gradient, and the third is the line of best fit. You will have to find out the gradient of all these three lines. Once you find out the gradient for all these three lines, you will subtract the one with the maximum slope with the minimum slope and then divide it by 2. So the answer for this example given is equal to 1.87 milliamperes per volt.